Hey everyone, welcome to the first Intro to Competitive Programming workshop of the quarter. You can follow our presentation on this link, and let's get started. So our goal is to give you the skills and confidence to solve a big range of competitive programming problems, and I want to stress that no competitive programming experience is required. So before I discuss our topics, let me introduce our team. So my name is Ilya, pronounced he, him. I'm computer science and engineering major, second year.
Hi, my name is Carson, pronounced he, him. I am a third-year computer science major. My favorite ice cream flavor is vanilla.
Oh, and my favorite ice cream flavor is chocolate.
Hello, everyone. I'm Tony. My pronouns are he, him. I'm a senior computer science and applied math double major. And my favorite ice cream flavor is coffee, I think.
Hello, everyone. I'm Jason. I'm a second year pure math major, and my favorite ice cream is cookies and cream.
Hey, great. So here you can see our topics for this quarter. These are tentative because we'll accept your feedback, your suggestions. So today we'll go over ad hoc problems. And if you don't know what that is, that's absolutely fine. Ad hoc are the problems that do not fall in the standard category with well-studied solutions. So you have to be creative. Okay, so you might be still wondering what competitive programming is. Well, in general, it's a competition to solve the greatest number of algorithmic challenges as fast as possible. I want to stress that this is not a hackathon where you build some web or web application in the limited time. In this case, you're faced with a number of problems and you're trying to get to the solution as fast as possible and make sure that your program runs with the given time limit. So it's more like problem solving, not software engineering. Why do competitive programming? Well, obviously, it's fun. On a more practical scale, it's also useful. These kind of questions you'll often see at the coding challenges and interviews when you'll be applying for jobs. And by the way, we have our famous interview track that's running workshops in parallel. Go check it out too. Well, competitive programming is social. Look at all you who came here today. And finally, you can get prizes. Well, there are a lot of coding programming contests like Google Jam and our own Code Sprint. And also, you can win money even on this workshop. Well, a little bit about our audience. So, as I said, no programming experience is required. You might be taking CS 30, 31, 32 series, or might never touch computer science at all. That's also fine. Only if you're interested in competitive programming, you're welcome. A little bit more about the workshop track and events we have this and next quarters. So this quarter, we have Intro to Competitive Programming track, this one. We have interview track and also team training. Next quarter, you can check out all the same tracks and even more. And finally, in spring quarter, we'll have advanced track, which touches on more advanced concepts of competitive programming. And finally, join a team. I'll give a little bit more detail of what you can do right now. So as I said, we have interview track, which is a workshop that teaches you how to strive in in coding challenges and interviews. It's called Friday 6 to 8 and Bolter 4760. We have the second tryout for ICPC team this Sunday, 3 to 6 p.m. at the same location. And finally, I think today applications for ACM internship just aired, so you can apply. And if you would like to be in our position and teach workshops, you can apply to become an intern. And finally, code sprint delay. It's something to look forward to. we usually hold our own computer science competitive programming competition in spring quarter, where you can showcase your skills that you learned during our workshops. So come check it out. That's a good motivation to come to our workshops. All right. As we're done with logistics, let's get started. Well, first of all, during our workshops, we are going to use Kattis, the cutest contest platform. This is where you will get all your problems and where you'll submit all your solutions. It will run automated tests against your solutions and give you a score or pass, no pass result based on the correctness of your solution. So now I would like to ask everyone to create a Kattis account. And once you're done with that, tell us your username. If you have any problems with creating a Kattis account, please raise your hand and an officer will help you.
And we just type in these things directly or go to the slides. And please make sure to fill out the second link so that you can tell us which email goes with which username so we know how to get prizes to you. This one is your slides. If anyone needs more time setting up their Kattis account, or is everybody good? Just raise your hand if you need any help still. Okay, so everybody has filled out both of these links, all set up and good. Kattis. Okay, great.
Okay, let's continue. So once we all have our Kattis accounts, let's talk about tools and tips that we are using here. And one thing I want to stress a lot about is please use pencil and paper. So many people think competitive programming as if a person seriously typing something into a computer, and sometimes that actually is true. But before you even start programming, you actually need to solve the problem. Because if you're trying to implement something you're not really sure how to code, this can lead to more bugs, to some confusion, and eventually waste of time. And remember, you need to do it you want to do it as fast as possible. So I would definitely recommend to draw it out, figure out some test cases. So do it on paper or whatever you use to take notes, and only after try to code your solution. Well, when it comes to coding, I suggest you use any programming language, whichever you are most comfortable coding with. We recommend using C++, and there are a lot of reasons why people love it and hate it. First, why it's good, it's very fast language. It's also taught in a lot of UCLA CS courses, and it has good standard library. However, there are some alternatives which you could use fine, like Java and Python. So you probably already have one of the editor or compiler set up, but if you don't, that's absolutely okay. A lot of Windows users use Visual Studio Code, and on Mac you can use Xcode. You can install it after, or if you already have it, that's fine. If you want to do something fast, you can use an online editor, and one of the good ones is REPL.it. You can go there right now, and it's very easy to use, pretty self-explanatory. And it also has different options like C++, Python, and Java. Okay, so I guess we're done with the logistics. So let's start problem solving, and I'll hand it over to Carson.
Before we get started, does anyone have any questions about anything we just covered? Anything at all, small or big? Okay, cool. So to start, we are going to have our example problem contest for this week, which will also have the other problems which you can do throughout the week for a chance to win prizes. But if you can go to this link on the slides right now and click the join contest button, and you should see the contest problems that we have prepared for today. And if you can go ahead and open the first one once you get in, it's called Boss Battle, problem A. Just take a couple minutes, join the contest, and give me a thumbs up when you're good with that. Okay, does everyone see a contest in front of them on their screens right now? Anybody still need help with that? Okay, cool. So let's break it down. How are we going to approach competitive programming problems when we see them in this sort of environment? Our first step is to read the problem. We have to understand every part of the problem and what it's asking in order to understand how we're supposed to go about solving and encoding it. Then we implement that coded solution, and then we would submit it to Kattis to get judgment. And Kattis, the judge, will tell you whether you got it right, whether you got it wrong, what your issue was if you got it wrong, and you can go back and fix it and resubmit. But in competitive programming, you will get a penalty for wrong answers. So make sure that you are testing things locally before you submit them to the judge, but we'll talk about that more later. So just to go over the process very clearly, we're going to go through this example problem boss battle with all 4 of these steps in depth. So first, we're going to read through and understand every single part of the problem and exactly what it's asking. We're going to solve the problem without code just by going through some examples, trying to figure out what the information the problem has given us and how we can use that to find the answer. And then we will implement that solution in code. And then we'll talk about some debugging tips in case you ever get stuck and you need to figure out what's wrong with your coded solution. And that is the process that we will go through. So first off, hopefully you're looking at this problem boss battle right now. On the top left is the problem statement. That's where it gives you all the information. We call it flavor text a lot of the time. Sometimes it's kind of important, sometimes it's not so important, but you have to read it either way just to be sure. And then there's some input and output descriptions, maybe an example with an image to give you some more clarification. And beneath that, you'll see your sample test cases, which are sample inputs that the problem creators have given to you to further explain what the format of the problem is like. So you know what sort of input you might get and then what you're expected to get back with that input. On the top right, you'll see that big box where you can start coding. And if you open that and you start typing code or pasting in from your own local editor, that's where you can upload your code and submit it. Or you can upload a file directly if you download a working program that is a coded solution. But most likely you will just directly paste in your code to start coding. But for now, just take a couple minutes and go ahead and read the problem description so you can understand the problem, and then we will work through it ourselves. Okay, does anyone need some more time to read through that? We will work through the problem also. Okay, let's get into it. So just to explain a bit what it's saying here, hopefully you got an idea of what the problem is. But essentially, there's n amount of pillars around a room. There's a boss hiding behind a random pillar, and you have to bring with you a certain number of bombs in order to defeat the boss. You're trying to determine what that number is, knowing that each bomb you throw will destroy one pillar and the two adjacent pillars, throwing out those squares, defeating the boss that's behind them, and then the boss gets to move on their turn, and you repeat until you either win or lose. So, to start off with, what does that really say? That means that if there's 3 pillars to start, if n equals 3, and we throw 1 bomb, so we blow up the pillar that we picked and the 2 adjacent ones and immediately win. So if there's 3 pillars, you know you only need 1 bomb to win. And if there's 5 pillars, for example, if you throw a bomb, sure, there's a chance that the boss is behind it and you win, but you have to consider the worst case scenario, as stated in the problem statement, in order to guarantee that you are always able to win. So that does not necessarily mean victory, and if you have more than 3 pillars, you're going to have to figure out some sort of strategy to beat the boss with. So what should you be thinking? How are you going to solve this problem? Just try imagining the worst case scenario. If you throw a bomb, what is the worst thing that the boss can do to hurt your chances of beating? Create a couple examples, run through them, run through a few rounds of the game and see what happens. Can you find anything out from this? Is there any information that you're able to retain between player turns, even in the worst case scenario with the boss's movement? And does this information help you solve the problem? And if you think you can come up with a solution to that, then you can check your work with the example inputs and the correct outputs that they give you. So just be thinking about that. Couple more hints. Another sample input that may be easiest to work through is n equals 5. So probably use that as a starting point and then try out 6 pillars and 7 pillars until you see a sort of pattern if you have an idea of how to solve the problem. And don't forget to consider any edge cases where values of n may be small and maybe your solution doesn't work as you expected. So go ahead and take a couple minutes and...
Do we have to declare like ISP templates and declare?
Sorry, what was...
But do we have to like input all the files?
No, don't even go about a coded solution yet. Just take some time and try to just find the answer on pen and paper, and then we will go over how to code it.
Oh, okay. Can we go back to the previous slide real quick?
Yeah,
For the one with box. No, you can let me do that. You can leave the reference.
Okay, I'm sorry to interrupt all of your diligent work. Hopefully your brains are turning and you're figuring out the solution to the problem. Maybe some of you already found like the trick to it and you know the solution. By the way, we are going to work through exactly how we come about finding that solution. And it may be simpler than you think. So let's just take a n equals 6 pillars example and just see what happens. So on our first term, we got to throw a bomb out somewhere. We don't have a choice. We don't know where the boss is going to be. So we throw one, we eliminate 3 squares, and we use our first bomb. Now, we didn't really find anything out from this. You know, maybe we defeated the boss, but maybe we didn't. So we have to assume the worst case scenario. And in the spirit of that, let's just assume that the boss is in every possible remaining pillar and that he makes every remaining possible move. So just so we cover all our bases, let's assume that the boss is in all 3 spaces and moves into the 2 outermost eliminated pillars. So we no longer have those pillars as places where the boss cannot be. He has moved into them potentially, and we can't be sure anymore. So let's just say that he's there for the sake of the argument. So on our next turn, we should just throw another bomb next to this one square where we know he can't be. So we can kind of corner him in, right? Instead of just throwing it across on the other side and having him have more options to move, let's just continue building our little circle around. So we eliminate 3 more squares, 3 more pillars. And now we have that little 4 section that he can't be in. And then on the boss's turn, they can move into the 2 outermost ones. And you can see that on our second turn with our second bomb, we have eliminated the second pillar for sure. There's no way that the boss can be there. And so if we do the same thing again, let's say we throw out the bottom pillar this time, now we've expanded our little arc to 5 pillars and there's only 1 possible place left the boss to be. And on their turn, they can move, but since there's only 2 more options, there's 3 pillars left. And we know that with 3 pillars, we can immediately win just by throwing a bomb right in the middle. So look at that. With 4 bombs, we won. Guaranteed. There's nothing that the boss could have possibly done in any case that would have allowed him to win if we bring 4 bombs to the n equals 6 pillar fight. So how can we generalize this? Well, that's essentially saying that after k turns, we will have eliminated k pillars. And when there are 3 pillars remaining, we know that we can eliminate them with 1 bomb. Therefore, we can eliminate the first n-3 pillars with n-3 bombs. And the final 3 can be eliminated with 1 bomb. So we can eliminate all n pillars with n-3 plus 1 or just n-2 bombs. That's it. The answer is n-2. But are there any situations where this formula doesn't work?
Well, if we have 3 bombs. If we have like 3 pillars, well, if we have like 2 pillars, then
Yes.
-2.
Exactly. So if we have 2 pillars or 1 pillar, our formula doesn't really make sense anymore because we can't kill the boss with n-2 equals 0 bombs or 1 minus 2 equals -1. So that's our edge case. And so we just say that for n is less than 3, we just need 1 bomb in order to defeat them. So that's our solution. Question?
Is there a way we can improve the correctness of this offer?
You know, probably, yes. I'd say that it's more of an intuitive proof. These are ad hoc problems, so you probably could formally prove it, but just knowing that we expanded our area of destruction as much as we could every single turn, and we considered every possible move that the boss can make, we can kind of confirm that this is the best that we can do. Okay, so we know the solution, but now we gotta code it. So how do we go about doing that? This is the beginner track. So if you need any help with anything, if you don't have any coding experience, here are a bunch of very helpful links about C++, which is what we will mainly be using to code our solutions and what all of the answers that you'll see will be in. If you want to use a different language, that is more than okay. But if you want some helpful links just to refresh you or maybe introduce you to the basics of C++, how to use hashtag include statements, and there's some simple program examples and input and output, then you can click on these links and you can go check them out. But we will explain pretty much everything in depth. Here is just a sample program. If you have not dealt with Kattis before and you don't know how it works, basically it requires you to read in everything from standard input and then output it to standard output. So there's a lot going on in just this simple program, but basically all it's doing is I'm declaring an integer, a float, and a string, and then I'm using these cin statements to pull them from the standard input, which is what Kattis gives to you as your input for the problem. Then you can do whatever you want with those variables, change any values you want, create new variables, and then by returning or outputting a solution, we mean using a cout statement to output the value of the variable directly to the console in your standard output. So that's just kind of what your solutions will look like, at least at the start and the end. Where that little dashed line is usually where all of your code will go and how you manipulate the input that you're given into the solution. But if you want to come look at this example anytime, it's there. So if you've ever done like a leak code problem or maybe some other similar website, a lot of those websites will take functions as their solutions, but Kattis and the most competitive programming contest platforms will require complete programs, which means header files, namespaces, and your main function. All you really need to know is that for most basic problems, you'll copy the same format and just do your code in your main function. And if you're on Windows, you can just use this hashtag include bit/stdc++.h header at the top of your program, and it will include all of the standard libraries and tools that you might need to complete a competitive programming problem. If you're on Mac, you can just stick to using the normal ones. It's not that bad. Usually you will just use IOStream and string and maybe vector algorithm. As long as you know those, you'll be a-okay. You can just include them on every program if you're unsure. But if you have any questions about that when we're coding, just ask me. So let's get into what a working program looks like. So we know the solution to boss battle. Reminder, if n is less than 3, we just want to output 1. So only need 1 bomb. And if n is greater than or equal to 3, in any other case, then we just need n-2 bombs. So using this starter code on the left, this is just including IOStream, which lets us do input and output, which is the cin statement, and you'll use a cout statement to display the correct answer. Using namespace std is just to use the correct namespace, and then you can pull in the input number n using int n and then cin n. So starting with this, see if you can fill in the rest, create the solution, and then upload it to Kattis. So when you go to the boss battle problem on Kattis and you see that top right box that says start coding, if you already have a solution and you've tested it on your local environment, you can run a couple inputs, see if it works, and then copy paste it over to Kattis to receive judgment officially. But take a couple minutes, see if you can code that up. Just copy this directly from the slides or just type it out and see if you can solve it.
Yeah.
Okay, hopefully everyone got a chance to try that. Hopefully right now what you see on front of your screen is a big accepted box. If not, here are some possible solutions to the problem. Most likely what you're going for is something on the left, which is just an if statement and else statement. If n is less than 3, we have the 1, otherwise we have the n minus 2. But you could have just switched the order and done if n is greater than 3, do n minus 2, vice versa, or you could have gone fancy and done the one on the right. And those are possible. The point is, you don't need to code it in one particular way. It's not looking to match an exact set of characters for your solution. All it's looking for is you to match the exact output. So as long as you give the right answer at the end of your program, it doesn't matter how you do it. These are all correct answers and will get you an accepted on Kattis. So if you want to just try typing that in and seeing what it's like to get those green check marks, then you can go for it. But we're going to move on. So let's say that you've been trying to figure out how to code the solution to a problem and you're getting stuck and you don't know exactly what's wrong, what you need to fix, what to do next. These are some tips for debugging. So on Kattis, when you submit, you will get a verdict, which is either going to be a bunch of check marks to say that you passed all these test cases and hidden test cases, which are used to evaluate the correctness of your solution, or you'll get something like a compiler error or wrong answer. As you can see, that means that you got those issues with your program and you need to go back to the drawing board and fix something before you submit again. So if you got an AC for accepted, then great, you got it all right and you can just move on to the next problem. If you got a WA for wrong answer, it means that one of the test cases failed. So given one of the inputs, you did not provide the correct output, even though your program ran okay, it didn't give you the correct answer. So you need to worry about maybe edge cases and other things and see if you can fix that. If you got a time limit exceeded, it means your solution was too slow. So you need to check for an infinite while loop, check that you're not doing anything repetitive and wasting time in your program so that you can make sure that you're meeting the time requirements. And if you got a compiler error, it means that something is wrong with your program directly, and you should always try to catch those before you submit to Kattis by testing locally in your environment. Those are just some of the errors you might get. If you want to look in the slides, here's exactly what that might mean and what you can do to help fix that. But hopefully everything is smooth sailing, and you can always ask us too. Last couple notes. You must follow the output specification strictly for a problem. That means no extra spaces between words, correct capitals, no extra empty lines, correct rounding of decimals, an exact number of digits and characters, decimal places used. So make sure that you're meeting all specifications for every problem exactly, and you should be good to go. And you'll never have to deal with debugging. It should be amazing and impossible. Just to recap, we want to read through and understand every single part of every problem that we look at. The problem statement, the input output description, make sure you're not missing any details, because one thing that you miss could make you solve an entirely different problem. Just the smallest detail can change a problem quite a bit. So make sure that you're reading through the whole thing, and then you're solving the problem before you even start to code so that you know what you're doing when you're coding and you're not just aimlessly trying to create this algorithm out of nowhere that doesn't come together. Having a solution first makes things way easier and way more time effective. And then if you get stuck and you aren't getting the right answer, then go back to debugging strategies. Just figure out exactly what the problem is so you can go fix it and move on to the next problem or to the correct solution. And speaking of next problems, let's move on to our second example problem presented by Leah.
Okay, so hopefully you got a grasp of how to solve and submit a problem to Kattis. So let's take a couple of minutes to read through the problem B, Faktor. Okay, hopefully you've read the problem. So essentially there are three numbers here. Total number of citations, number of articles, and impact factor. And basically impact factor is the number of citations over number of articles rounded up. And in the problem, you're given two numbers, number of articles and impact factor, and then you need to figure out the minimum number of citations that would be enough to get the following impact factor. So there are three things, I want to reiterate three things of how to approach the problem. First of all, you need to read the statement. And I want to emphasize this part because if you read one word wrong, you're wasting your time solving a different problem. Oftentimes, problem statements can have a lot of flavor text, can be long, and it might be tempting to just jump into coding. However, it's always important to read through the entire problem statement and make sure you understand it. Next two parts is reading through input and output specification. That's where you'll find all about the variables you're given, about the format the input is given in. For example, here, you're given two integers, you know the type of the numbers, and then their bounds are from 1 to 100 for each of the integers. And then you're expected to write out another integer that satisfies the specifications above. And finally, work through sample cases by hand. Oftentimes, the problem statement will have a couple of examples of input and then the correct output that's expected by the testing program. Keep in mind that there are also secret test cases that will not be given to you. So your solution has to work for all those test cases. However, it's good to work through sample input to better understand what's going on in the problem. And that's what we are going to do right now. So let's look at sample input number 3. We are given 10 articles and we want impact factor to be 10. Can you guess how many citations minimum we need? What the output is? Does anyone have any suggestions? What the answer could be? Yes?
91.
Yes. Can you explain why? Why it's correct?
I just like figure out this pattern that you multiply the first one by the second one, and then you subtract the first one and then one. And you
Okay, great. Yeah, exactly. So the answer here is 91. And indeed, if you divide 91 by 10, you get 9.1. And then by the problem statement, you should round upwards and you get 10. So I guess sample case 1 works in the same way. You would divide 875 by 38, and you get the second number, impact factor, -1, but just a little bit more. So because you're rounding upwards, you'll get the desired impact factor. So you might already guess the solution, but it might be a little unclear what the pattern is. So what I suggest is that we write our own test cases and work through them by hand. That's also a good practice for any problem. Write your own test cases because the problem author will not always give you the most convenient test cases, and you would want to design your own cases. So imagine we have 3 articles and our desired impact factor is 6. Let's test out different number of citations and see what impact factor we get and if it's desired. So if we have just 1 citation, our impact factor is 1. Which is 1 over 3 and rounded upwards. If we have 3 citations, impact factor is still 1 because 3 over 3 is 1. If we have 4 citations, then impact factor is 2 because we get 1 and 1/3, 3 rounded up. We continue doing that, and let's say we get to 15, then the impact factor is 5, 15 over 3. And finally, we add 1 more. We get 16 citations, and impact factor is 6. Even from here, you might guess what the pattern is, and oftentimes it's pretty much enough. You're not required to submit a mathematical proof. You just need to submit your coded solution. That's why you have to be pretty sure that solution you wrote works, but you don't need to know exactly how to prove it. But in this case, I'll show why it's correct. So let's generalize it. For example, we have n number of n is the number of citations needed, x is our desired impact factor, and a is number of articles published. We are given x and a, and we need to output n. So the claim is that this is the formula to find the least number of citations. You multiply the number of articles by target impact factor -1 plus 1. In other words, when you divide n by a, you will get x -1, but just a little bit more. So because you round upwards, you'll get the desired x impact factor. So for example, if you have 10 articles, then indeed you multiply 10 by 9 and add 1, 91 citations. Does anyone have any questions at this point? Why this formula works and how we got there? Yes? So by the you mean here? So by the problem statement, we need the minimum citations needed. So if we had let's say 100 citations, we would get impact factor 10 as well. 100 by 10 is 10. However, if we want the minimum citation, we just need just a little bit over 90 citations, and 90 is you get it by multiplying the number of articles by impact factor just -1. So when you, let's say you divide by 10 by our number of articles, you get x -1 and just a little bit more, 1/8. So then when you round it up, you get the desired factor. That's why it's x -1, not x. Any other questions? Okay, so how would we go about coding it? In fact, it's not that complicated. You just read in 2 integers and then you just write out the formula. So I guess you can try to submit the problem if you tried it before, or I guess you can if are there any more questions? Okay. Okay, let's one quick announcement. If you were considering to do tryouts, the second tryout is not in Bolter 4760, but in Engineering 6289. And we updated the slides.
Okay, so hopefully now that you've done a couple problems, you have some experience, you get what Kattis is like and what the process is for going about solving these problems. Let's dive into our third example problem for the day, lost lineup. So if you go to problem C, lost lineup, and just take 2 minutes and read the problem. Go. Okay, so hopefully you've had a moment to think about the problem and what it's saying. So let's go through some explanation. So the wording of this problem is a little bit tricky. at least when I first read this problem, I know that I was a little lost. I didn't really exactly understand what it was giving me and what it expected me to do with that information. But essentially, all you need to know is this line here. The second line contains n-1 space separated integers, where di between 0 and n-2 is the number of people between the i+1 person and Jimmy. In other words, all that sentence is really saying is that person i+1 has di people between them and Jimmy. And as you hopefully read the problem, Jimmy is always our first person in line. So using that information, we can kind of break down where each person is supposed to be in the line. This table kind of gives you an idea of exactly what is given to us. So on the left column is DI, which is our input values, which we got in our sample input. In this example, n equals 4, so there's 3 other people, and we know that the DI value for each of them is 1, 2, and 0, respectively. And now, the way the problem is laid out, those numbers that are given to us are like the first, second, and third numbers. So that's our I value for this problem. And then it wants us to find the person number as the I+1 person, which is kind of strange, but it's basically just saying that take the I, so like the first input you get will be person number 2. And the second person you get will be person number 3. And so just add 1 to I, which is like the index of what input you're at, and that will give you your person number. And then you can just take that information and translate it into this sentence and kind of understand what it means in English. So person 2 has 1 person between them and Jimmy is what DI equals 1 as our first input means. And so on and so forth. Person 3 has 2 people between them and Jimmy. Person 4 has 0 people between them and Jimmy, knowing that Jimmy is always at our first position in line. And our job is to find the final order of where people were before they got mixed up. Does anybody have any questions about that before we explain further?
How will the input be written?
The input will be read in using CN like before. So there are a couple examples.
Like for the second space, will it be inputted as an integer or will it be input as integers or like a column string?
So it's just input is a string of characters. That's how all Kattis problems are given. But by using CN, it automatically pulls everything up to the next set of white space. So if you pull like just a number by doing that, it will be able to be stored as an integer. So it's okay that it's just a bunch of characters. If you just use CN directly into an integer variable, then it will store those numbers one at a time.
You do need to be in the correct number.
Yes, that's why they give you n as the first input, because that will tell you how many times you need to pull numbers from standard input. Okay, so let's go through a little exercise with it. Can anyone tell me, based off of what input I am given here in sample input 1, that means for our first column right here, and where in line that person would be? Yeah.
Person 2 has 3 people between Jimmy and person 2. That person would be for the last person.
Yes, exactly. So that's basically what we're doing. Can anyone tell me for the second column or second row in the meaning column and where that person is in line, what that means?
Yeah, so person 3 has 1 person between them and Jimmy.
And so where would they be in the line?
It'd be third place.
Yeah. So does everyone understand that process? You take the input value, you add 1 to the I value of that input, that's your person number, and they have that input number of people between them and Jimmy, so you can place them at that position, knowing that information. So do the last 2 just quickly. Person 4 has 0 people between them and Jimmy, and person 5 has 2 people between them and Jimmy, and that gives us our final order. And that would be our sample output 1, 4, 3, 5, 2. Is PD. So if there are K people between Jimmy and some person, what is that person's position in line? Knowing that the first position in line is position 1. Close. It's actually going to be K plus 2. Because this is a 1 index situation, it requires you to add the K people in front of them and Jimmy, and knowing that they start at position 1. So if we have K people between Jimmy and someone, then they're automatically in line at position K plus 2. And so how do we go about coding that answer? To start, if you haven't seen arrays in C++ before, here's a quick overview. You can look at this in depth in the slides. You can go down to the array tutorial on the link on the bottom of the screen if you haven't seen C++ arrays and get familiar with them. But they're pretty straightforward. It's basically just a tool to store a bunch of different integer data in a row. You can declare an array in these ways. You can make one of a fixed size, like int array 5, and you can set the values directly. You can make an array of strings, and you can set the values of those using this format. Or you can create a variable size array by declaring a variable like n here, and then creating an array of size n, which is hint what you might have to do for this problem. And you can access array values using the brackets. So if you declare an array like ARR here, and then you want to access the values, arrays are 0 index. So the first value will be array 0. You access this way, and then you can just set the value of an integer variable directly to it. And I will put that value in the variable. So first element here would be 1, and array 2 will give you the third element in this array. So value 9. And you can also set specific values in arrays. You can do so in a for loop using a variable. You can access the array like this and set it to whatever value. So if you go through this for loop 5 times, setting each value in the array to the value of the for loop index, then you will get an array with 0, 1, 2, 3, and 4. Does anybody have any questions about arrays before we tackle the problem?
Could I use vectors instead?
Yeah, you can absolutely use vectors. Whatever format you want to use, go for it. Vectors are great. Arrays are probably the simplest thing for the problem, but vectors are totally fine too.
You arrange the file paths from vectors, do you, right? Because like how we can.
You know, there's a lot of optimizations to vectors, so they may be faster, but for the input that you're given for this problem, it's going to be such a negligible difference that it shouldn't really matter. Lots of vectors. Okay. So here's some starter code to help you out with solving this problem. If you didn't get any of the include statement and namespace stuff, then just copy this and then fill in your solution to exactly what we discussed in our solution written out in that question mark area. But basically all I've done in this starter code is giving you an array declared to be of size n that you take from the input. And then at the end of the problem, I output every number in the array. So all your job is to do is set the array to the correct answer given the input. So you have to take the rest of the input from standard in using cn statements, and then do something with that input to set the values of your line array to the correct ordering so that at the bottom when they get output is in the correct order. And if anybody has any questions about any of that, I can go out and walk around. It's just
First, number of people between them, I think, you know, this is simple. It's like, it's very about so and you know how to refer to what you so if you want to take that rest of one person, one person, and the next person is going to be three. So they so you already have spending.
Yeah, no, I don't know. Okay, this is like what I did, and I also did different.
Okay.
So basically I take things, right, and then I create a rate. Because it's an excited one, the thing goes one. Then I basically I break over.
Yeah.
So I do one. So obviously just it's not really right. So I keep taking like these values, then I go my volume of k plus 2 minus 1 would be I plus 1 because yeah, and then you go back 1, that would be the index index right, right, then so I go for in I plus 1 that was I plus plus and then just bring you
So, and it's trying to do a lot of outputs. So if X consider like 3 people, how many values each account?
so it's extra 3.
Yeah, how many times do it? Yeah.
Okay, 0.
Yeah, there's only one.
Yeah.
Zero next to That's the most common mistake, it's like one off error where you're putting out.
I was like, I'm getting like 3. I got 2 that are missing. Everything's I know.
I see that, but it's pretty, yes. But I think they figured it out. It's not. Whoever defines.
Oh, yeah.
Well, that's not what I was gonna say.
Okay, I'm like.
I mean, okay.
You make sure you can set up all the gear and that's that line.
Now,
Yeah.
But I know that I have to switch it, and then that was like.
Yeah. Right out.
yeah, that's probably, I think, what I should do.
But, yeah. Yeah, but then I don't usually like sort of thing. I usually.
Say about first line is how you have to like, yeah, so second line is number one. The second line is, you know, like nine questions.
Yeah, but I think it's still very, like, yeah, but I'm just like, figure out how to do it.
So, first of all,
I don't think. Like.
Maybe we just.
yeah, next. I would say first line you do it. So. Yeah, definitely reason like all the lyrics, right?
Yeah.
But then this reason then okay. So yeah, then I think that all in one.
Man.
No, like go back to the website. So let's say it's one line or only one integer, right? Or you need to do in Python and stuff, but I don't use slides.
Yeah,
Let's just get to a single number.
right.
However, the second line is going to be tricky because it can be one number or it can be three.
Yeah. So and you could split and make it a six.
Yeah, yeah. However, you can't do an you can't just because inside of here, goes into the gives you
Yeah.
so it's only word this thing goes.
Oh, okay.
So what you want to do is
Yeah.
you can use it in the form.
So, you know, so that's what you just.
That way.
You want to start at one.
Oh, then you make it.
Yeah, you have each one.
But how do I make sure this is different?
Oh, yeah, because. Yeah, I think it's.
So, okay, so this all you have. Like. Oh.
Or like there's order. It's just we'll see how and then see if you want to I'll execute some function.
Oh, yeah,
So what you can see is how I can project
yeah. Or.
That's what you did. And now it's for each split you
You choose like the variable that you take. Or if I could just choose. With like. This one is like not really.
right?
I don't think so, because I think the limit is just people.
Oh. Yeah.
Alright,
But you want to keep it, you want to keep that one because.
Oh, yeah.
You want to get it out first.
Yeah.
Oh. Oh, okay.
Yeah. I think. Yes, I think it's.
Okay, unfortunately, we're almost out of time, so we're gonna have to cut that problem short. Do you guys want me to display the solution, or do you want to keep working on it this week? And you can go check the solution on the slides if you want. Any consensus? Do you want to see the answer right now, or do you want to? Yeah. Okay. So the solution, sorry to everyone who's still working, is to set the first position in line to 1, because we know that Jimmy is always at position 1. And then as we iterate through the rest of our people, starting at I equals 1 and going up until n, we just pull in all those numbers by declaring our integer k and c in to k. And then we set position k plus 2 minus 1 to I plus 1 in our array. That's in order to, I wrote it this way instead of just writing k plus 1 to emphasize that we're still putting the I plus 1 person at position k plus 2, but the problem is 1 indexed and our C++ arrays are 0 indexed, so you gotta subtract the 1 to make sure that you're changing the right position. Once you do that, it should automatically put everyone in their correct position. Jimmy is at position 1, and so when we output, we should have the correct order. So what's that? Does anyone have any questions about how that works? Okay. We're gonna do Kahoots in a sec. If you can stick around, no pressure.
Okay, yeah. This is the feedback form. This is for any open-ended feedback you want to submit. You know, if you like the workshop, didn't like what you want to improve, any topic suggestions, please feel free to fill it out. And then there is a contest that's open for the entire week. We're the same contest that we're working on, and next week we'll decide on the winners, and they'll get Amazon gift. So, right, something about contest that usually in coding competitions, the problems are not really sorted by difficulty, but in this case, they're all sorted by difficulty from the easiest to the hardest. And but also, if you're stuck on a problem, just feel free to check out the next ones. And problem D, paragrams, we actually have a write-up solution after this extra problem. So we have a solution here, so feel free to check it out. Right. So this is the end of our first workshop. We will have a quick Kahoot after, but feel free to leave. Then thank you for coming.
Thank you guys so much. And if you want to stick around for Kahoot, I'm gonna put a.
Yeah, we'll have a small Kahoot, funny Kahoot.
Yeah, it's short. But
Short, very short. Yes.